In this question, can't find what you're looking for? Let's compare modern tools for finding files and finding files by their contents. So, in order to find files, right, we've touched on that a little bit with ls, with tree and exa. But what if we want to do some heavy-duty search for very specific files? And I don't care about using the shell expansion of glob. I want to use something a little bit more robust. Well, we have tools like fd and find. And what I want to show you here is their call signatures. fd looks much more confusing than find, right? Find has what, like 5 options? That must be not too hard to deal with. But find hides all of its complexity in this expression syntax, and we'll get to that. Find is an extremely powerful tool, and we'll actually see that the direction that fd takes it in it says, I'm not going to make something more complex than find. They've already done that. I'm going to make something a little more streamlined, and that's what fd does to modernize it. So here you can see I run fd, and I'm just saying find me everything that lives under this example folder. I get a nicely colorized output by default, and it's not much different than if I just ran this, with ls with a recursive glob. Let's do the same thing with find. Find, you'll notice I had to pass this -regex flag for a regular expression to let it know that my pattern is not a glob pattern. It is in fact a regular expression. Find defaults to using glob patterns, whereas fd defaults to using regular expressions. And if you've used both, you'll know that regular expressions are quite more powerful. They are more powerful. However, they are also more verbose. So it's nice that both of these tools give you the option to use either one that you want, depending on what you're kind of looking for. And so just to highlight that, fd also has a -glob flag, and so I don't need to pass in the .star. I can just give it a star. And this is how find supports file matching. You can test if the name of the file matches anything, in this case a wildcard. And that will run and it'll find pretty much the same thing that our regular expression example did. What's very interesting is when I run fd and search for a PYC file, it doesn't come out. But if I were to run find and search for a PYC file, oh, there it is. Well, it's just hiding in there. What happened? fd, modern tool, Git support. And you'll see this repeatedly, every example. I'm going to highlight it because one of the biggest changes in how developers work now versus how they were used to work is everything is version controlled. Pretty much everyone uses Git, GitHub, whatever. And it is a fantastic option to start including this. Now that's a part of our daily life, to start including this in our daily usage of tools. They should be able to support things like parsing git ignore, automatically ignoring that .git folder, etc. So fd follows git ignore, and it ignores hidden directories by default, because that's also another shift in kind of development style. Back when computers were first about, there weren't many hidden files that you would have. Now, I think I have a hidden file for every single program that's ever been installed on my computer. It's a config file or a settings file, or it's a hidden folder that leads to like 8 different profiles depending on how you want to run things this time or the other. So having the ability to automatically ignore hidden directories by default, fantastic. Another pattern that you see all the time with find is, well, I'm not doing anything fancy or complex, just show me all of the JSON files. And fd has a shortcut for this. You can just search by file extension given this -e flag. And again, we're going to match any file, so any file that has ends with JSON inside this example folder. And you see it does that for us very readily. You can also combine, you can put multiple file extensions, so give me anything that's a JSON file or a txt file. And it's not a very verbose command. It's pretty easy to read, pretty easy to write. Whereas with find, you have to remember that One, you're matching on the name of the file, and you have your glob pattern ending in JSON. And now we need to include this -o. What does this mean? This is an operator for or, right? So if this is our expression in the find command, we're saying for each file, match its name to JSON, and if that checks out, give it to me, or match its name to anything that ends in .txt and spit that out and give it to me. So it works incredibly well. It's very powerful. I hope you can see the underlying structure and how you can make very complex queries, except it comes at the price of verboseness. And so that's what you'll see here. FD is just more streamlined than find. Find will let you do very powerful things, though. It also has some kind of common sense shorthand flags. I don't know if you've noticed, but find does not have any double dash flags with a shortened single dash kind of character keyword there, whereas FD does. So in this example, it should be FD find. I've been aliasing it. So in this example, you see that we're just searching in our topmost level directory here, right? So this is the same thing as limiting the depth on tree that you saw earlier, but this is really a feature that find has had for quite some time. And so we can run the same command with find. Yeah, a little more verbose, does the same thing. Also, what are those hidden files and folders doing in there, right? So if we want to make sure we ignore those, we'll have to add some complex query here. And so now what are we doing here? We're finding an example, anything that's of type D, -A for and, it's not a path that starts with a dot. Okay, so we're finding a directory that's not hidden, any directory that's not hidden. I had to really read through that. The FD command that does the same thing is just FD-T for type, FD find, -D for type. And guess what? It ignores hidden files, hidden folders automatically. We just get the same output as this really long find command, just more streamlined. So, where does FD not hold up? Complex expressions. FD can only support case matching, not case matching, or smart case matching. And this default is smart case matching. All smart case matching means is if the pattern you supplied is all in lowercase, it will match uppercase as well. It sounds insensitive, but if you were to throw in an uppercase letter into that pattern, all of a sudden it will be case sensitive by default. In find, we have to explicitly say if we want to perform an case insensitive match or a case sensitive match. And we do this with -iname for insensitive or name for sensitive match. And so we'll see here we get all of the files that start with file or start with response. We can also find by file type, right? So this will find me any file that file permissions. This will find me any file that is executable, which is just a very nice convenience to have. And we can also perform complex queries. We can combine these tests, right? Now find me any file that ends in .sh or is executable. And we could swap out that or for an and to find out where they overlap. And lastly, we have another complex command, right? Find me type F stands for anything that's a file, and that is also executable. And then we can also test if the name ends with .sh. And this gives us one shell script that's a file and is executable. So now, my friend's boss wants you to execute some command on each of these scripts. Now that we know how to navigate through our file structure, now that we know how to find things within our file structure, what if we want to execute things? Well, FD has a very, very nifty method of doing this with the -x flag. Let me set up my alias here so you don't see the word find repeated. And so when I run FD, all I'm doing, this isn't the output of FD. This is actually being echoed back in, and I can prove it to you. The output, the command output of FD, if you're using the -x flag, you can send in, or you can have it kind of cut up the file output. So here you can see I have trimmed off the extensions from every single one of these outputs, and I'll show it to you on top of each other so you can see. You can see the upper half all ends in .py, .py.sh, and the lower half has their file extensions completely trimmed. This is very useful if you are piping this command in order to do some type of file conversion, right? And you want to just get the base name of the file and then maybe change it to something else in the output. Or it's kind of like make in that sense. Or if you want to maybe specify a single file that exists and it might have multiple parts to it, so you don't specify the full path, you just give it the path, up to and including the stem of the file name. In this example, by passing a slash inside the curly braces, we have trimmed off all of the path leading up to it, and we can do even crazier things by trimming off just the file name and leaving the parent directories leading up to it. And we can even mix and match some of these things. Just give me the file names with no file extension. This is something that find does not do readily for you. And one final thing, you'll see here that I've passed capital X here. And the difference between the lowercase x and the capital X is lowercase x says, execute this command on each one of the found files, whereas the capital X says, execute this command, except use all of the files you found and pipe it into that single command. So here I'm doing a advanced ls-lh because this is not something I can very easily capture just by using glob patterns. And find does support execution here, or executing on its file outputs. However, you can see the verbosity just skyrockets here. And it does not support any of the dots or slashes within the curly braces to pipe in some other part of the located file into your output. So, my thoughts. I really, really liked FD. I thought it was a great tool because the majority of times that I'm using things like find, I don't want to combine like 80 expressions. I don't need anything that powerful. I'm just doing the relatively simple things. Give me, what are all the JSON files here? What are all the text files here? Show them to me. Ignoring hidden directories is a huge plus in my book. I think that should be an opt-in thing now, especially that there's bajillions of hidden directories and folders that are always in our file system, and the smart case matching is very convenient. Find has, it's more, I wouldn't say robust, but it's more complex, right? You can develop very powerful, complex queries, and the expression syntax is very, very useful in that case. And now, instead of searching files by their names, what if we need to search for files by their contents, right? This is where tools like grep come in. So if we grep on all of the files in our example folder, we can see that, and we ask it to find any instances where we see the string hello, it spits back each of those files where hello was detected, as well as the line that it was detected in. And we can do neat things. We can recursively search on this. We can return the count, right? So instead of giving back the line, we can count how many times the pattern was matched within a given file. And we can even perform an inverted match. So we're saying, give me all the files and all the lines that do not have hello in it. And so grep is a very useful tool. You can use it to search for just about any regular expression inside any file. Did I say any regular expression? What about things like pipes, capture groups, or curly braces? You'll see when I run this grep with a pipe in the middle to separate, to say, give me any line that has hello or shell in it, I don't get any output. This is where grep with the E flag comes in. It stands for extended regular expression. This command is also referred to as egrep. It is the same thing. Egrep was kind of split off from grep and then merged back in as a flag. And And so grep-e is actually, it's extremely powerful. I love it. But what about modern grep? This is where things like ripgrep come in. Bam, modern tool, human readable output right off the bat. I get colors for free, not for free, but I get colors. I get spacing between each of the files that my output is located in. Just a fantastic, and I get the highlighting of the exact phrase that matched. Very nice to look at, very easy to read and deal with. So in this case, you can just see I want to find all the files with import in them. I can give grep a -r flag, and look here. We have one file that's in my .get folder. Usually when I'm looking for things, I don't want to accidentally find them in the .get folder. So let's see, does ripgrep have those other modern features? Of course it does. It ignores hidden directories and hidden files by default. Lastly, before we finish up with the topic of grep, I want to share with you a tool called semgrep. I don't have an example for it. However, there is a link to semgrep.dev/playground. It is a semantic grep. And what does that mean? Well, if you've ever tried to parse HTML with a regular expression and gotten some weird output, or seen that really famous Stack Overflow answer, hopefully you'll know what I'm talking about. Regular expressions are used for parsing regular English or regular language. It's not useful for parsing things like programming languages where there are different patterns. So we need a different tool to very robustly parse programming languages. And semgrep does that. I can say, in every Python file, show me any function that also has a print statement in it. Show me any lambda that is defined within a class, defined within a function. You can get these levels of nesting that you will have to jump through hoops to extract using a regular expression, and you get a very nice, not very verbose, input when using semgrep. So my thoughts, I really liked ripgrep. Ripgrep was fantastic. It's at least as good as egrep. Honestly, base grep, kind of out the window for me. I really like expanded regular expressions. But the thing I love about ripgrep, all those nice modern features, respects.getIgnore, defaults to ignore hidden files. It can actually search zip files too, which is a very handy thing. It'll actually temporarily unzip it for you, parse contents, return anything that returns for you, and also the human readable output for interactive use. I don't use grep a lot in a shell script, but I will use a lot when I get a directory with a lot of data in it, or a lot of different folders, and I'm just searching for specific things.